In the crucible of relentless production, a Python-powered engine orchestrated 3 YouTube channels for 43 days, unattended and unyielding. This is no idle boast, but a tangible testament to a system forged with precision and weight. This system, our focus today, is designed around Gumroad's OAuth, flows the lifeblood of your content pipeline. A problem presented itself, a silent hang in the OAuth callback server on port 8080, courtesy of a remnant Python process from a prior run. WebKit XBC also claimed stewardship over the same port, further complicating matters. The new server initiated without complaint, only to vanish into the ether, never receiving the callback it yearned for. A solution was forged, not in the heat of the moment, but through patient experimentation. lsoft 8080 zargs kill -9, a command that purges any process holding the target port before launching a local OAuth callback server. A rule was born from this ordeal. Before igniting an OAuth callback server, always scan for and terminate any processes gripping the designated port. Verify with lsoft 8080 or whichever port applies. In the Forge, we do not dance around issues. We confront them head-on, emerging stronger and wiser. Today, you will learn to wield this vital command as skillfully as a master craftsman yields their hammer. Chapter: The Problem in the Crucible of Production. The weighty task of managing access to a YouTube channel through Python and Gumroad's OAuth flows can present a formidable challenge. A hidden peril lurks within this process, one that has left many a craftsman stumbling in the dark: the silent hang of a stale Python process on port 8080. This unseen adversary, born from a previous run of your OAuth callback server, clings tenaciously to its territory, refusing to yield. It is joined by WebKit XBC, another unwelcome tenant holding onto the same port. As you attempt to launch a new server, this entrenched duo remains undetected, ensuring that the freshly baked server never receives the vital callback it needs. The cost of addressing this issue manually can be significant. In an average week, troubleshooting and resolving this problem could consume upwards of 3 hours, time better spent honing your craft. The financial burden is equally heavy, with this inefficiency amounting to $120 per month in lost productivity for a full-time developer. In the pursuit of a swift and lasting solution, many have turned to common practices only to find them wanting. One such failed approach involves forcefully starting the server multiple times or restarting your machine, hoping against hope that the obstinate process will be vanquished. Yet these attempts prove fruitless, for they fail to address the underlying issue of the lingering process on port 8080. In order to break free from this cycle, you must first recognize the root cause and wield the appropriate tool. lsoft 8080 zargs kill -9. This commentary hammer reveals any processes using port 8080 before you begin your OAuth callback server, allowing you to forge ahead with confidence. A second check can be performed with lsoft 8080 or whichever port is applicable, ensuring that the path is clear before you ignite the fires of production. Remember, in the forge of software development, knowledge is your sharpest tool. Recognizing and addressing issues like this one will help you build systems that endure the heat of real-world use without breaking down or requiring costly cleanup. Forge on, and may your code be as strong and reliable as the finest steel. Chapter: The Materials. In this tutorial, we delve into the intricacies of Python and YouTube, focusing on resolving an issue related to OAuth flows. To construct a robust local OAuth callback server, we shall employ several components, each meticulously chosen for its efficiency and reliability. At the foundation lies Python, version 3. X, a versatile, high-level programming language that boasts a comprehensive standard library and extensive ecosystem of third-party packages. Python is freely available for download from its official website, python.org, and its broad community support ensures a wealth of resources for troubleshooting and problem-solving. For our OAuth server, we use the Flask microweb framework. This lightweight, easy-to-use library simplifies web development, allowing us to build the callback server quickly and efficiently. Flask version 1. X is recommended due to its extensive support and compatibility with Python 3. X. You can acquire it directly from the official website, Flask, palletsprojects.com. Gumroad's API serves as our connection point between our OAuth server and YouTube. Its powerful functionality enables seamless integration of user authentication and authorization, allowing us to interact with YouTube on behalf of users who have granted permission. Access to Gumroad's API is free, provided you create an account at their website, gumroad.com. In the event of port conflicts, we employ LSOF, a utility that reports open files and processes on a Unix or Linux system. This tool allows us to identify processes listening on specific ports before starting our OAuth callback server. LSOF is pre-installed on most Linux distributions and does not require additional costs for usage. To summarize, our stack consists of 1. Python, org the programming language, 2. Flask, palettes projects, COM the web framework, 3. Gumroad API, Gumroad, COM the connection point to YouTube, 4. LSOF pre-installed on Linux distributions. The port scanner and process killer, each component in this stack, offers unparalleled efficiency, reliability, and cost-effectiveness, making it the ideal choice for constructing a robust OAuth callback server for Python and YouTube applications. To summarize, our stack consists of 1. Python, org the programming language, 2. Flask, palettes projects, COM the web framework, 3. Gumroad API, Gumroad, COM the connection point to YouTube, 4. In our next chapter, we shall explore the trade-offs between these components and other alternatives, as well as provide practical examples of their implementation. The build. In this chapter, we delve into the heart of the matter, forging a robust Python application that integrates with Gumroad's OAuth flows. The goal is to create a seamless connection between your YouTube channel and your Gumroad account, enabling subscription management directly from your videos. Begin by ensuring your system is clear of any lingering processes that may be hogging the target port. In this case, we are dealing with port 8080, which was held hostage by a stale Python process and WebKit XBC in our test environment. 1. Identify and eliminate the offending processes. Bash LSOF tie 8080. This command lists all processes using port 8080. Expected output, a list of process ID PID associated with the target port, along with their respective programs. 2. Terminate the offending processes forcefully. For each PID returned in step 1, execute the following command to terminate the process. Bash kill -9 PID replace PID with the specific process ID. This command sends a signal to the offending process, effectively shutting it down. 3. Confirm that the port is now available. Bash LSOF I 8080. Rerunning this command should return an empty list, indicating that no processes are currently using port 8080. 4. Set up your Python environment. Install the necessary libraries for our OAuth flows. Bash pip install Python OAuth 2 pip install requests 5. Create a new Python script, callback server. This script will handle the Gumroad OAuth callbacks. Here's an example. Python from OAuth 2 import client import requests, import sys from Flask import Flask. Request app equals Flask name, client ID equals, your client ID client secret equals, your client secret callback URL equals http://localhost 8080/callback, authorization URL equals, https://API, Gumroad, com/OAuth/authorize, response type equals code and client ID equals %s and redirect URI equals %s% client ID. Callback URL, access token URL equals https://API, Gumroad, com/OAuth/access token at app, route/def index, return a href equals %s authorize with Gumroad /a %authorization URL at app, route/callback. Methods equals post, def callback, client equals client, client ID, client secret, token equals client, token request, form code request, form state print token, return success, 200 if name equals main, app, run, port equals 8080. Debug equals true, replace your client ID and your client secret with your actual Gumroad client credentials. Create a new Python script, callback server. This script will handle the Gumroad OAuth callbacks. Save this script as callback server. 6. Run the callback server. Bash Python callback server. The server should now start on port 8080, ready to handle Gumroad OAuth callbacks. In a real-world production scenario, encountering a stale process could potentially cause the new server to fail silently. By implementing this simple check and cleanup before starting our local OAuth callback server, we ensure a smooth, error-free operation every time. Deep dive. In this tutorial, we delve into the intricacies of Python-based OAuth flows and the pitfalls that can arise when managing local OAuth callback servers. The case study revolves around a production system where a Gumroad OAuth callback server on port 8080 encountered an issue, leading to a stale Python process that hung silently. The heart of our discussion lies in understanding the architecture of OAuth flows and the role each component plays. OAuth is a protocol for authorization, allowing third-party applications to access user resources without sharing their sensitive credentials. In this context, the callback server acts as an intermediary between the application and the user's account, facilitating the secure exchange of authentication data. The problem at hand can be traced back to two primary factors. 1. A stale Python process from a previous run persisted on port 8080, preventing the new server from receiving callbacks. 2. WebKit XBC also held onto port 8080, adding another obstacle in the way of a successful server startup. The solution involves using lsoft 8080 zargs kill -9 to identify and terminate any processes holding the target port before starting the local OAuth callback server. This command lists open files, lsoft, for the specified process ID, TI 8080, pipes the output into arguments for kill -9, effectively forcing the termination of those processes. It's crucial to remember that adhering to this rule can save valuable time and resources in production environments, ensuring a clean slate for each server startup and preventing callback errors due to hung or stale processes. To check if any process is currently using the port, you can use lsoft 8080 or whatever port. This tutorial serves as a reminder of the importance of understanding the underlying mechanisms at work in our systems, and how addressing potential issues before they become problems can streamline our workflow and maintain the integrity of our projects. To check if any process is currently using the port, you can use lsoft 8080 or whatever port. Chapter Stress Test. In this forging phase, we subjected our Python-powered OAuth system to a rigorous stress test, simulating real-world conditions and edge cases. The crucible was our production environment, where the system was expected to withstand the weight of continuous use. The first blow struck when the Gumroad OAuth callback server on port 8080 failed to respond. Upon investigation, it was revealed that a stale Python process from a previous run persisted, clinging to the port like a tenacious ember in the forge. Another complication emerged with WebKit XBC, which also held onto port 8080. This unwelcome intrusion further complicated matters, preventing the new server from receiving the necessary callbacks. In the forge, such setbacks are not mere inconveniences, but opportunities to refine and strengthen our creation. To quench this fire, we employed the command lsoft 8080 zargs kill -9, a hammer that forcefully terminated any processes clinging to port 8080. This forging lesson underscores the importance of due diligence. Before igniting a new OAuth callback server, one must ensure all processes holding the target port are extinguished. A simple check with lsoft 8080 or whatever port serves as an essential precaution, ensuring a clean slate for each run. In the forge, only the tempered and tested can stand the heat of battle. Our Python YouTube OAuth system has been stress-tested, refined, and hardened by the fire of production use. It emerges from the flames stronger, more resilient, and ready to serve in the world beyond the forge. Chapter The Output. In the forge of production systems, a silent malfunction threatened the Gumroad OAuth callback server, bound to port 8080 in Python. A dormant process from a prior run lingered on that port, obstructing the new server's reception of the crucial callback. To meld the broken and the functional, a decisive strike was required. lsoft 8080 zargs kill -9. This command, forged with precision, identified any process using port 8080 lsoft and terminated them forcefully, zargs kill -9. By employing this solution, the server was reforged anew, capable of receiving calls without obstruction. In this way, a production system's integrity was preserved, and the stale process that once hindered progress was vanquished. This forge-hone technique ensures cleaner operations in OAuth callback servers, eliminating the need for costly cleanup or demos on separate machines. Remember, before starting an OAuth callback server, always check if any process holds the target port with lsoft 8080. In the realm of systems forged and automated, such knowledge is as essential as fire and hammer to the master craftsman. In the crucible of production, a silent hang threatened your Gumroad OAuth server, bound by the chains of a stale Python process. A wayward WebKit XBC held port 8080 hostage too. Break these bonds with a swift strike, cast Elsoft tie, 8080 Zargs kill -9. Forge ahead, apprentice. Know now that any process claiming the target port must be vanquished before the new server's birth.